Number one less than twice a number. How would you write that here?
2 minus 1.
You could have put a different variable and it doesn't have to be yours. If we are evaluating the expression where x is -1 and y is 3, you should put both of those into this expression. 3 times -1 squared minus 3 squared. What answer do we get? There. -6. 3 minus 1. For the third one, we need to solve this. So we can start off by distributing 7x minus 6 equals x plus 6x plus 30. Combine our like terms. At this step, what type of solution is this going to have? No solution. Questions on those? And then number 4, we needed to find the domain of this. So you could write this in interval notation or in set builder notation, either way. Reading left to right, the furthest point left on this graph is at -1. So in interval notation, what would this be?
-1 to
-1 to infinity. Parentheses, brackets. Parentheses for the infinity. Bracket for this one. In set builder notation, if you were doing this, it would be your x line. This starts at -1 and keeps going, so this would be x is greater than or equal to -1. Either or. So your set builder notation is kind of like your inequality answer. Both of those are the same thing. So hopefully now when you see domain and range, or at least for domain, you're thinking kind of inequality, you're thinking interval notation, and you can still think about it that way. Walk me through how I solve this for y. Okay, go ahead.
Minus 3x and greater as well. And then you bring the operations as -2y equals 3x plus 8. And we divide by 2 on both sides. -2. And we divide it so it's 1 equals 1 x.
Yes, 3/2. Do you have any questions on that? Hopefully with each of these, you start to remember more of this and you get a better feel for these. Eric, do you have a question? Right. Before we get into our notes for today, I want to talk a little bit. So look at your course calendar. One thing you should notice, it's short. It is very short. So that doesn't mean that these are set in stone dates as any course calendar. It really depends on our understanding and how we feel about it. If it gets extended a couple days later, that's fine. If it probably won't go shorter than what's on that paper. There's only 2 objectives on this. Simplifying radicals and then radical operations. And total, there'll only be 3 Khan Academies for this. 2 will be due this week, 1 will be due next week. Right? Because this is short, if at any point in time you have questions or you're confused by something, you need to ask in class or come see me before or after school to get that clarified. Do not sit in confusion. That does not help you. It does not help me. Okay? While we're thinking in the future, the last day to retest will be March 31st. That's the Thursday. So if you need to retest, I would say get it done as soon as possible because the last day to retest is the 31st. That means if your retest stuff is not done on the 31st, you may not have time to retest on the 31st. So keep that in mind. That will also be the last day to take missing tests. So if you're missing Unit 6 tests or Unit 7 tests, come get those done ASAP. Okay, questions on any of that? Alright, so everyone should have these notes in front of them. And we are going to start these notes today. I'm going to pull this down so you can see what these are. Honestly, I don't remember. Okay. So these are just some vocabulary. Go ahead. Right. When talking about a radical, we're talking about the root itself. The index could change. Most of the time we talk about a square root. So if we're talking about a square root, the index is 2, but we don't usually see the 2 out there. It's given, assumed. But we have seen like a cube root before, and then the index would be 3. There is no amount of, or no limit to what the index could be. There are 4th roots and 5th roots and roots. It keeps going. We are only going to talk about square and cube though. Right? Whatever is inside the radical is the radicand. So what we're trying to simplify, we're getting an answer. So this next sentence is really for if you were to take the square root of 4, the square root of 4 is what? 2. But that's just the positive version of that. Really, there's a negative version as well, because negative 2 times negative 2 also equals positive 4. But when we're simplifying, we're only looking at the positives, not the negatives. So we don't really have to worry about that. Right? Anyone still need this? We are going to list the first 12 perfect squares. So some of you may know those already. And if you're not sure what I mean by that, you're going to take 1 times 1, tell me what that is. 2 times 2, and tell me what that is. I'm going to do that up to 12. So what would the first perfect square be? 1. The second perfect square, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11, and 12. So if you're not sure where these numbers come from, you would take 1 times 1, 2 times 2, 3 times 3, and so on and so forth. We could keep going. 12 is a good number to stop at. 15 is a good number to stop at. 20 is a good number to really stop at. Usually you don't need no more than 20. You can just use your calculator. Like I'm here for 15. Then I get kind of lost between 15 and 20, and I know 20. So as long as you know a good majority of them, you're good. Right, so some of these we should be able to do without the calculator, but some of them you may need the calculator. So the square root of 16 is 4. Now for number 2, we have 2 times the square root of 121. So simplify the square root first. Square root of 121 is 11. And then we're multiplying by 2. 289 may not be something that you know, but it is 17. If you're not sure, in your calculator, hit your square root button, second x squared, 289, and it would give you 17. So we're going to do 6 times 17. Someone do that, tell me what you get. 102. Okay. Anyone know what the square root of 400 is?
20.
20. So we do 3 times 20, which is 6. So if you know what the perfect square is, it's really easy to simplify that. But a lot of the times we won't know what that perfect square is, or what this square root is, and that's where the simplifying part comes in. So the rules or steps that it says, I'm going to show you multiple ways to do this, and you're going to pick and choose which way you feel better about, because it may be confusing one way and not the other. Right. So one way. Let's do the longer way first. Give me some factors of 32. So what times what would give me 32? 8 times 4. Okay. And if you think of 2 others, that's fine. It does not matter the 2 factors you think of. So this is just one way to do this. So I know 8 times 4 will give me 32. When you do this way, you want to break these numbers down until they're prime. So which means the only factors they can multiply is itself and 1. So is 8 prime? No, it's 4 prime. That means we can break them down more. So what times what would give us 8? 4 and 2. And then what can we break 4 down?
2 times 2.
2 times 2. Is 2 prime? Yes. So that means we just need to break 4 down again for 2 times 2. So once you've broken it down completely, then because it is the square root, you're looking for pairs of the same number. So here we have 2 or a pair of 2's. Even though we have 3 here, we can group 2 of them together to make a pair. However many pairs we have are going to come out of the radical or come outside of the square root. So I would have 2 times 2 on the outside of the square root. Whatever does not have a pair would stay on the inside. And then I would simplify. So this would be 4 times the square root of 2. This way will always work. Sometimes this will get a little lengthy because of the factors and we need to break it down a lot. But this way will always work. Before I show you the other way, what questions do we have on this? And this will work no matter what factors you choose. It would be the same answer if you chose 16 and 2, 32 and 1. I think those are all the factors. It does not matter. You would get the same answer no matter what. Yeah. You're talking about the 2 on the inside? Yeah. Yes. That's why it's still on the inside. This would be your final answer. We can't simplify it more, but if I were to put this and this in the calculator, which I'll do really fast, it's a really big decimal. And I do 4 times the square root of 2, I think. Okay, there we go. You get the same thing. So we're not looking for the decimal answer. We don't really care what that is. We care that they match. That's really it. What we're looking for is to try to get this as simple as possible. Take everything out of it that we can and simplify it. That's what we're trying to do. Okay, the other way to do this, I'm going to do this off to the side, is to think about the highest perfect square you can divide this by. So think about your perfect squares, look at your list. What is the highest perfect square I can divide this by? 16 and 2. Now 4 would work, but that's not the highest. I can't do 9 or 25, but 16 would work. So then I would break this down into 2 different sets of square roots. The square root of 16 times the square root of 2. This would be the equivalent of the square root of 32. And then we know the square root of 16 is what? 4. So this is the simpler way to do this, yes. But when these numbers get really big, you may forget or not see what is the biggest perfect square you can divide, and then this becomes a longer process. If you chose 4, you would have to do part of this and part of this. I'm going to show you what I mean by that. You don't have to write this part down, but you can if you want. So if I chose the square root of 4, the square root of 8, I know the square root of 4 is 2, but 8 is not a perfect square. That means I would have to break down 8 like I did for 32 over here. So here I will be listing out the factors, 4 times 2, and then I have to break it down again, 2 and 2. So then you would have the 2 that came out already. That square root of 4 became 2. So that would have come out already. Then we have a group of 2's that's also going to come outside of the square root. And then the one leftover 2 that would be on the inside. So it would be like a mixture of this method and this method. Would that still work? Yes. Could that get confusing? Also yes. But regardless, pick a method that works best for you. So that's because it was actually the square root of 16 is 4. So here we're not breaking this down. We're actually figuring out, okay, the square root of 16 is 4. That would like come outside. Do you have any other questions on that before we move on to some others? We'll do this one both ways, and then every other one after will alternate. Easier. I would say this one, just because it's usually shorter. If you pick the highest number. If you don't pick the highest, then I would say just do this. Alright. So doing the shorter way first. We need what is the highest perfect square I can divide 180 by. So if you're not sure, start dividing. 180 by 144. 180 by 121. See if you get a full number. Okay. 36. 36 and what? When you divide 180 by 36, what do you get? 5. So if we were doing this the shortest way, you know this is the square root of 36 times the square root of 5. The square root of 36 is what? It's 5 cannot be simplified anymore, and that would be our final answer. Now we're going to go back and do it this way. Besides 36 and 5, give me 2 factors of 180. 18 and 10. Neither of these are prime, so we need to break them down. Give me 2 factors of 18. 9 and 2, 6 and 3 would also work, so would 1 and 18. And then 2 factors of 10. 5 and 2. Okay. Of all of these, the only thing we can break down again is 6 to get 3 and 2. Here we have 2 2s and 2 3s. So those would be the pairs that come out. The only thing that would be left on the inside is the 5 by itself. So we'd have 3 that comes out, a 2 that comes out, and the square root of 5 would stay in, which would be 6 times the square root of 5. So do you get the same answer? Yes. It's just longer. Let's skip to, we'll do one more of these and then we'll skip to another thing. Let's do 48. We'll do this the short way and then the next one the longer way. For 48, what is the highest perfect square we can divide it by? 16. 16 and 3. The square root of 16 is 4. So our answer would be 4 times the square root of 3. So unfortunately, the only way to check yourself with these is to put this in the calculator and see if these decimals match. If the decimals don't match, you did something wrong and you have to figure out where that was. So that would be doing it the factoring method, and yes, you could do it that way. We're going to do 10 using the long way, the factors, finding the factors. This has a 2 at the beginning already, so that means we need to bring that down at the end after we found out all of our factors. Give me 2 factors of 54. 9 and 6. Now 9 also happens to be a perfect square, but we're not doing that in this method. Give me 2 factors for 9. 3 and 3. 2 factors for 6. 3 and 2. We have one group of 3s that can come out, or one pair of 3s that can come out. And then the 3 and the 2 are going to be left inside. So we have the original 2 times 1, 3. So anytime you bring out a number, you're just representing this one group with one number. And then on the inside, 3 times 2. So what would our final answer be? 6 times the square root of 6. So I'm going to put that in our calculator just to make sure we did that correctly. 2 times the square root of 54 and 6 times the square root of 6. So that works. Do you have any questions on this so far? Let's do 2 more of these and then I'll let you go back and press them. We'll do 11 and 14. For 11, let's do this using the shorter method. I changed my mind because 384 is a bigger number. Let's do this one using the longer method and we'll do 14 using the shorter method. Give me 2 factors of 150. 15 and 10. Okay, and then 2 factors of 15. 5 and 3. 2 factors of 10. 2 and 5. Do we have a pair?
Yes.
Yes. Of what? 5 and 5. So we have the negative 5 that was already there. That's going to stay on the outside. And then we have the 1 pair of 5s that gets to come out. And then we have a 3 and a 2 on the inside. What is our final answer? Negative 25 times the square root of 6. Once you get the hang of this, it's not that bad. You just have to think of factors. Right? For 14, if you need to write out your factors, your perfect squares, you can do that. This may be something bigger than these. Yeah, that's in this one. But find which of these, the highest of these, we can divide 384 by. 64, and what do you get when you divide by 64?
6. Okay.
Second. Square root of 64 is what? 8. And we have the square root of 6. But we need to remember that 4 on the outside. So what would our final answer be? Not 32. I'm going to put that in the calculator, make sure we got the same answer. So 4 times the square root of 384 and 32 times the square root of 6. Beautiful. Okay, there are some ones that we skipped over. Number 7, 8, and then 12 and 13. I'm going to give you 5 to 10 minutes to work through those 4, and then we'll come back and check them, and then start on cubes. These answers are only going to show one method, so if you want to see the other, let me know. So for number 7, final answer, 7 times the square root of 3. 8, the final answer, 5 times the square root of 7. Do you want to see either of those a different way? Or do you have questions on either of those? Amina? 7. And give me 2 factors that work for 1 and 7. So that would be 7 and 3. 7 and 3 are both prime numbers, so we have a pair of 7s that come out, and the 3 that stays in. Any other questions or need to create the other way? For 12 and 13, 12 was 64 times the square root of 2. 13 was negative 6 times the square root of 7. Questions on either of those, or need to see those done the other way? Overall, how do you feel about simplifying square roots? Thumbs up if good, sideways if okay, down if not good. The next part we're going to do is simplifying cube roots. Some of the same rules apply, but they're also a little different. Right? Does anyone need this before we move on? Right. We're going to list the first 10 perfect cubes. 10 is really good for cubes because these get really big really fast. These you may not know off the top of your head, so if you're not sure what they are, in your calculator you would do 1 to the third, 2 to the third, and keep doing that until we get all of our perfect cubes. So 1 to the third is what? 1. 2 to the third, 8. 3 to the third, 27. 4 to the third, 64. 5 to the third, 125. 6 to the third, 216. 7 to the third, 323. 8 to the third, 512. 9 to the third, 729. And 10 to the third, 1,000. These went from 1 to 1,000 really fast. Okay. So just like our square roots, if we know our cube roots and they're perfect cubes, then we can simplify it easy. The cube root of 8 is what? The cube root of 343 is 7, and we're multiplying it by 5. So 31. Now, I don't think I did this with the others, but really quickly, in your calculator, do the square root of any perfect square that you want, but make it negative. So the square root of -9. Okay. So square roots cannot have negative numbers. But if we were to do the cube root is in math number 4. If I did the cube root of -9, that works no problem. I'm sorry, not 9, because 9 is not 27 or 8 is what I meant. Let's try that. Okay. We can take the cube root of a negative, because really that's the same thing as me saying -2 times -2 times -2. -2 times -2 is a positive, times another negative makes it negative. And it's okay. Those are allowed. So we have the cube root of -27 is -3. The cube root of -1,000 would be -10 times 2 is -1. Great. I also want to adjust that just a little bit. Think about this like the cube root of 27 and the cube root of -1. I'm going to do this off to the side. Because what's really allowing that negative is the cube root of -1, because that's just -1. And then we have the cube root of 27, which is 3. So when we get our final answer, we get -3. So when we get negatives in the future, we're going to separate it out like this, but we'll cross that bridge when we do it. So again, there are 2 methods to doing this. It's basically the same methods. You can do the factor tree and find the factors. Instead of pairs, because we're looking for cube roots, we're now looking for groups of 3. And then when we do the find the perfect or the highest cube root that would go into this, we're just looking for a cube instead of a square. Okay, so let's do 19. Let's do both methods. We'll do the longer of the 2 first. Give me 2 factors of 40. 4 and 10, 8 and 5, 2 and 20, any of those words. So here, it does not matter that these are not perfect cubes or anything like that. I'm just finding my factors, breaking this completely down. 2 factors of 4, 2 and 2, 2 factors of 10, 5 and 2. So with cube roots, we need groups of 3, not just pairs. So here we have a group of, group of 2. Since we have a group of 2, that group gets to come out and it will be represented by its number 2. We have 2 times the cube root of whatever is left, which would be 5. Before we do it the other way, what questions do we have? Using the other method, now we're looking for what is the highest perfect cube we can divide 40 by. So we have the cube root of 8 times the cube root of 5. The cube root of 8 is what? 2. We cannot simplify this anymore, so this would just be 2 times the cube root of 5. What questions do we have on that one? Aubrey? You said where I get the 2 from this one?
Yeah.
So here, 2 to the 3rd equals 8. If you were to put that in your calculator, so if you're not sure about these, definitely put these in your calculator. I didn't need a second. So the cube root of 8 is 2. 2 times 2 times 2 is 8. So you either need to know those or be able to put them in the calculator to find them out. With these, it may be easier to do the factor tree method than to think about the perfect cubes. But if you want to go that route, you still can. Let's jump to one of these other ones. We'll do 21 and 22. So for 21, we'll do both methods, and then 22, we'll do one of them. For the shorter method, of all of our perfect cubes, what is the highest we can divide 432 by and get a whole number? So if you're not sure, do 432 divided by 343, divided by 216, 125, and keep going. So that 16 and 2. The cube root of 216 is what? I'm just writing this in so that we know what these are. That's 6, yeah. And then we can't simplify this anymore, so this would be times the cube root of 2. If, when you write this, the 3 looks like it's more for the 6 than the root, you can use parentheses. Put parentheses around the cube root. That way you know that it's separate. That way you don't confuse it. Say that again. And then the long method, besides 216 and 2, give me 2 other factors. I'm sorry. We forgot one thing. The 2 on the outside. So what would our final answer for this be? 12 times the cube root. So don't do that. Don't make my mistake. Bring down the 2. Make sure you multiply them in. Now, using the longer method, give me 2 factors of 432 that are not 216 and 2. Four and 108. So you might be breaking this down for a little bit. That's okay. 4 will give us 2 and 2. So that's good. Now we just got to focus on 108. Give me 2 factors of 108. And it's okay if you just use 2 the entire time.
108? Oh, 108. I heard something else in mind.
Under 4 and 27. Okay. 4 we can break down to 2 and 2. Now, before, I was waiting until the very end to find out your groups. You can do that as you're working or at the end, it doesn't matter. So like here, I definitely have the group of 3, but I'll wait till the end. 27, give me 2 factors. Oh, you're 9 and 3. And then 3 is good, but give me 2 factors of 9. We have a group of 2s, a group of 3s, And then we have that one lonely 2 that's going to stay inside. We have the original 2 from the outside. The group of 2s that gets to come out, the group of 3s that gets to come out, and then the key group of 2. So that would be 4 times 3 is 12 times the key group. So this one, the shorter way was the easier way because the number was so big. So it also depends on the factors you choose. What questions do we have on that one? We're going to do the short method for 22, and then we'll do, oh, there isn't more to that, right? Yeah. So short method of this, and then I'll let you practice these remaining 3, and then we'll see what else time we have. Right. So when we break this down, I'm going to say -2 times the cube root of -1 times 250. So I'm really just looking for what is the highest perfect cube I can divide out of 250. 125. Numbers like that should be recognizable as 125 is going to be one of them. Okay, so this is going to come out as a -1. That's not hard to do that. And then we said times the cube root of 195 and 2. I don't know if we said 2, but let's pretend we did. We have -2 times -1. The cube root of 125 is what? 5. And then times the cube root of 2. So -2 times -1 times 5 is positive 10. Right? And we haven't done this in a while. You can still check your calculator with these two. Check to see if the decimals are the same. So I'm going to do this one in the calculator. -2 times the cube root of -250. And 10 times the cube root of whatever number it is. What questions do we have on this process before I let you practice them on your own? If you haven't already, try numbers 20, 23, and 24, and we'll come back in about 5 to 10 minutes to go over that, and that'll be the last thing we do today. Quickly go over those, and then if you have any questions on those, we'll go over those. Again, this is just one method, so if you want to see the other method, let me know or ask. If you have questions, also ask. For number 20, your final answer was 4 times the cube root of 3. I'll read off all the answers, and then if we want to see it done the other way, we'll go back to that. 23 was -16 times the cube root of 12. And then 24, -9 times the cube root of 7. Anyone need to see any of those 3 done the other way? Or have questions on those?
Actually, never mind this one.
Which one? 4. Okay. You had a question about it, or you want it done the other way? So give me two numbers that are factors of 1 to 10.
27.
And then breaking it down, okay. So here we have 9 and 3, and 3 and 3. So one group of 3s we get to come out. We have -3 times this group of 3, and then times the cube root of 7.
Oh,
Does that make more sense? Other questions on those 3? So you do have a Delta Math and 2 Khan Academies. The Khan Academies are due on Friday. However, listen before you keep packing up. You have plenty of time, I promise. One of them, I would definitely wait until we do our next part of this lesson with the variables. So wait until after we meet again on Thursday. The other one, the exponents and radicals quiz 2, you could do that today. You could wait. It is a mixture of finding the square root when it's a perfect square, finding the cube root when it's a perfect cube, and then there are some that have decimals or fractions. Really quickly, just so you see what that would look like. You might get something that looks like this. If you have something like this, this is the same thing as taking the square root of and separating this. The square root of 4 over the square root of 25. The square root of 4 is what? 2. The square root of 25 is what? 5. You have 2/5 instead of a decimal. Same thing with decimals. They'll give you something that looks like it should be a perfect square, like we know 144, the square root of 144 is 12. So this is going to be something related to like 0.12 or something like that. So those will also be mixed in to that other one. So you could do that now, you could wait. The Delta Math is not due until 2 classes from now because it has all the variable stuff. So you could start on that, but it is not due next class.